This video, we're going to talk about adding integers. Integers are signed numbers. They have a positive or a negative sign that tells us which direction they're at on the number line. So here's the real number line. And the positive side of the number line is to the right, and the negative side is to the left. All of the numbers that we've been dealing with up to this point have been on the right-hand side of the number line. We're going to start to deal with some numbers that are over here on the left-hand side of the number line as well. So imagine that these are two teams playing tug of war with one another. When I add the numbers together, as like me seeing which direction this flag that's in the middle is going to move. And I'll show you. It's important to understand these signed numbers because we deal with them a lot in science with something called a vector. Don't worry what a vector is. It just has magnitude, which we talked about with absolute value, and direction, which we're talking about now with the positive and negative sign. So if I add things that are going in the same direction, I take 4 steps to the left and then I take another 5 steps to the left, I'm going to continue to be on the left-hand side of the number line. So I'm going to start at -4, and I'm going to move 5 steps in the negative direction. So 1, 2, 3, 4, 5. I'm going to count -5, -6, -7, -8. I'm at -9. Do you have to use a number line to do this? No. I can say that there's a rule that says if they have the same sign, I keep the sign and I add their absolute values and I get the same answer. Now I'm going to add two numbers that have unlike signs. You're going to see how the number line is going to help me here. I'm going to start at 2 and I'm going to move 1 in the negative direction and I get to a +1. So my rule for this tells me if they have unlike signs to keep the sign of the bigger number and to find their difference. So I'm going to keep the positive sign, and there it is. It works the same way whether you use the number line or not. Since addition can be done in any order, it also doesn't matter with this problem. If I would have looked at -1 + 2, and if I would have started at -1 and moved 2 to the right, I still would have gotten to +1. So I really like this number line method. It really simplifies the rules down for me. Now I have, let's see, that was 2 plus -1 I did. I've done -4 plus -5. Now I'm going to move on to -4 plus 2. So here's 0, 1, 2, 3, 4 to the left. And I'm going to move 2 to the right. And I'm at -2. I have -6 plus 5. Here's -6, and I'm going to move 5 in the positive direction. 1, 2, 3, 4, 5, and I get to a -1. -7 plus, sorry, -3 plus a -7. Let's use our rule here that says the signs are the same. Keep the sign and add the absolute values. That gives me a -10. I want to see that on a number line. Let's go ahead and put 0 more over here because I have to have a lot of spaces here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to start at -3 here. I'm going to move 7 in the negative direction. 1, 2, 3, 4, 5, 6, 7. Oops, I started in the wrong place. -3. 1, 2, 3, 4, 6, 7 will end me at -10. Now I have -4 plus 3. That's going to give me one, two, three. I stop at -1. For my last problem in this section, I have 14 plus a -2. 14 is too far away from 0 for me to want to draw a picture here. They're unlike signs. I'm going to find their difference and keep the sign of the bigger number. That's 12. All right. That's it for addition. We're going to come back and subtract next time, and subtraction is going to be very similar to this. We're just going to say that subtraction is addition of the opposite, and we're going to turn it into an addition problem and go from there. All right. See you for the next video.